My paper title is Deep Data Analyzing Application based on Scale Space Theory in Big Data Environment. This paper introduced the basic scientific idea of the multi-scale to the field of big data analysis, proposed a multi-scale framework of data analysis in big data environment, present the multi-scale algorithm framework of knowledge conversion theory and apply the algorithm framework to the multi-dimension association rules analysis. The proposed multi-scale association rule analysis algorithm uses the benchmark dataset of analyzing results and the inference weight of the benchmark datasets for target scale datasets to derive the association rules behind object scale datasets, realize knowledge across the scales derived and provide the possibility for multi-scale decision. Part 2. Theoretical foundation. This part has two aspects. A. The general essence of multi-scale data analysis. We can draw the essence of the scales is the size of a unit of measurement range covered. Also, the scale of the performance of spatial data in time and space in areas. In general, the performance data for other category scale, but their principle and nature has not changed. Net objective scale data are weighted dimension of benchmarking scale data. Therefore, after making the appropriate dataset generally concept hierarchy to form a multi-scale dataset generated between the sample data, structure information, regionalized variables. According to the distribution of data, select the appropriate ranking that achieve the general scaling data. B. The typical scale up and scaling down method. Multi-scale data analysis algorithm framework is based on multi-scale association rule analysis algorithm. First, clear association rules analysis in the target knowledge. For association rules and analysis, the association rules the process of time and computational sources consumed mainly in frequency items that analysis. So multi-scale association rules analysis algorithm to solve the core problem is the benchmark data set of frequency items that derived object scale data set of frequent item set and frequent item sets multiple convention and round target scale data set analysis. Part 3. Algorithm analysis. Compared with the classical data analysis algorithms, the advantage is that the proposed algorithm is only a reference scale analysis data set. In addition, the proposed algorithm itself enforcement mechanism to deal with the first reference scale dataset, and then the results of the multi-scale analysis are derived. If the idea of parallel computing applied this algorithm, the number of reference scale analysis parallel dataset, and then collect result of parallel processing scale up or scale down be converted and derivation will have a more. The multi-scale characteristic refers to the dataset itself. Some attribute or attribute set is related to geographical space or time, or other relative size and size range, that clear scale meaning, whether in theory or in practical algorithm. The theory of multi-scale data and the multi-scale data analysis algorithm are more suitable to have multi-scale characteristic of the data set compared with the experimental result of population data set Fig1 and Fig2. It can be found that the accuracy of the algorithm for scaling up operation is better than the scaling down, but the accuracy of the scaling up and scaling down parts are relatively high. From Fig 1, A, B shows that the upper part of the coverage and accuracy are more than 90%, and in some cases even reached 100%. From Fig 2, A, B reflected in the coverage and accuracy is slightly worse than on the scaling up, but also is more than 80%. Above experiment results verify the accuracy and feasibility of the algorithm. It shows that the IRM's algorithm is able to obtain the real frequency item sets of target scale data set from the frequency item set contained in the benchmark data set. Part 5. Conclusion. This paper proposes its algorithm framework for multi-scale data analysis and present the association rule analysis algorithm for multi-scale big data. The algorithm uses benchmark data sets analysis result and the influence weight of benchmark scale data set to the target scale data set to derive the association rules behind object scale data set. Realize knowledge across the scale derived and provided the possibility for multiple criteria validation. Finally, we conduct experiments to verify the accuracy and efficiency of the proposed algorithm. The experimental results show that the algorithm has a high coverage and accuracy and has a low support degree estimation error, and the efficiency is higher than the traditional a priori algorithm. That's all. Thanks.